Welcome to qnawire.
In this question, we are given this setup whereby rod AB is moving to the left with a velocity 10 meters per second, but is slowing down with an acceleration of 16 meters per second square. Okay, so we need to determine the angular velocity and angular acceleration of link CD at this instant, and theta is given to be 60 degrees. Okay, so we need to write down the position coordinate equation. So the origin is at E. We will write down the x coordinate of B. Okay, x coordinate of B. Okay, so this equation is going to be from here you have two right angle triangle. You can see it. Yeah, two right angle triangle, and then so x is just made up by minus 2 times the length, which is 0.3 cosine theta. Okay, I'm using this coordinate system whereby going to the right is positive. So since B is to the left of D, so you have negative sign in front. Okay. Okay, now we have the position coordinate equation, and then we are going to do two time derivatives. So x dot is minus is 0.6 sine theta dot, and then x double dot is 0.6 cosine theta dot square plus sine theta double dot. Okay, so we are given that theta is 60 degrees. X dot, which is our V, is minus 10, and then our x double dot, this is our acceleration, this is 16. So we are working with this equation, the velocity and the acceleration. Okay, and then we also note that theta dot is omega, theta double dot is alpha. Okay, so from equation 1, so we have minus 10 is equal to 0.6 sine 60 degrees times omega. So omega is equal to minus 10 divided by 0.6 sine 60 degrees. Okay, and then if you calculate, you get minus 19.2 radians per second. Okay, then the next thing will be our angular acceleration. So from the second equation, we have 16 equals to 0.6 times cosine 60 degrees omega square plus sine 60 degrees alpha. So alpha will just be 16 1 over sine 60 degrees, 16 divided by 0.6 minus cosine 60 degrees, 19.2 square. Okay, and calculate, you get minus 183 radians per second square. Okay, so this is the answer for omega, and then this is the answer for alpha in this question.